talk about the bell word. What am I supposed to be doing with these two rational expressions?
Simplifying.
Supposed to be adding them together. So what do I need if I'm supposed to add them? Common denominators. Are these two denominators the same?
No.
No. To find out whether or not they have anything in common, what do I need to do? I need to factor them. Does the first one have a GCF at all?
Yes.
4 is the GCF.
Second one has 6.
Second one has a GCF of 6. So our first fraction would become 5 over 4 times what? What do we have left after we take the GCF out?
X minus 2.
X minus 2. Plus x minus 3 over, I'm going to take the GCF of 6 out, and what do I have left?
X minus 2.
X minus 2. So do they already have anything in common?
X minus 2.
X minus 2's. So I need to give them the same denominator. I want to think about this for just a moment. If I had 1/4 plus 1/6, what should my common denominator be? 12. So what would I need to multiply the first fraction by in order to get 12? 3, top and bottom. And what about the second fraction? 2. Top and bottom gets multiplied by 2. You could. That one means that you'll probably have to reduce at the end, but that's okay as long as you remember to reduce it. Yes. So I would have 15 over 12 times x minus 2 plus 2x minus 6 over 12 times x minus 2. We have the same denominator? Then I can just add my two numerators together. 15 plus 2x minus 6 all over 12 times x minus 2. Are there any like terms that we should combine together? 15 and the minus 6. What do we get when we combine those two? What is 15 minus 6?
9.
9. Positive or negative 9?
Positive.
Positive 9 over 12 times x minus 2. Can this reduce at all? No. So that would be my final answer. If you had 24 instead of 12 as that number out in the front, you'd be able to find a common factor of 2 in the numerator, a GCF of 2 that you could pull out and reduce it with. All right, let's look at number 2. Which of these numbers cannot be probabilities? Anybody have a guess for me?
A.
A, cannot be. That is correct. You cannot have negative probabilities. You would never wake up in the morning and they said there's a negative anything % chance of rain today. There is one more here that cannot be a probability. Really? Which other one? Yes. This one right down here cannot be a probability. Remember, the probability of 1 is the same as 100%. It's a guarantee. And so this one down here is like saying 100.1%. And that's not possible. Probabilities have to be between 0 and 100%, or between 0 and 1. Can't get any bigger than 100%. All right. Do you guys have any questions for me on the bell work? Okay. We are going to talk about something called permutations and combinations. If you do not have one of these yellow calculators out on your desk in front of you, you're going to want to grab one, because I'm going to show you some of the buttons that we're going to use for these. We're going to talk about the difference between a permutation and a combination, and then we're going to practice identifying and calculating these. So in a permutation, order makes a difference. The order of selection makes a difference. So page 250 up at the top, underneath the word permutation. The things that are selected are going to be treated differently. The things that are selected will be treated differently. In a combination, order doesn't make a difference. The reason that the order of the selection makes no difference on a combination is because all the things that are picked are going to be treated exactly the same. We have buttons on the calculator for both of these. For permutation, the button that we're going to see looks like this. Do you guys remember on Friday how I had you push the PRB button? I want you guys to push that button again. The third option down was the exclamation point for factorial. Do you see the button that says NPR? What's the other button there? NCR. What do you think that's for? Combination. So here's the way we're going to use these buttons, and we'll practice using them here in just a second. We're going to type a number in first. That's what goes in for the N. This will be the total number of things that we're choosing from. So this is our whole big group, however big the initial group is. Think about when you're trick-or-treating and they hold the basket out to you and they're like, pick 2 pieces, but there's more than just 2 pieces there, right? So however many candies are in the basket, that would be this number here. And then the number that we are going to select, we will type in after we push the either NPR button or NCR button. All right. About ready to get started with this. total we choose from goes in first. Then we're going to type in whether it's a permutation where the order of the selection makes a difference, or the NCR for combination where the order of selection doesn't make a difference. Then we type in how many objects from that whole big group we're going to pick, and then we hit the enter key. Okay? So let's practice that on this first example. Still on page 250. A team of 8 basketball players needs to choose a captain and a co-captain. So how big is the large selection pool? They're choosing from how many people? 8 people. So the first number that I would write down is an 8, and it gets written kind of small. You can go ahead and type in an 8 on your calculator. They're going to select a captain and a co-captain. Will the captain and co-captain be treated exactly the same, or will they have different responsibilities? So is it a combination or a permutation? Permutation. In a permutation, the things that are selected get treated differently. So after you type in the 8 on your calculator, I need you to push the PRB button and choose the NPR. You should see that pop up on the screen right next to the 8, right? Okay. How many out of that whole group of 8 are they going to choose? 2. So then you're going to type in a 2, and you're going to hit enter. What did you get? 56. There are 56 different ways of choosing a captain and a co-captain. "56 different arrangements of people holding these jobs." Yes, sir.
So would this basically be a compounded version of factorials?
Sort of. It is based on factorial. We don't have, with our kind of brief touch on probabilities, we're not going to get into the formal formulas for these. We're going to use the button on the calculator. But yes, the formal definitions involve factorials. Yes. All right. Number 2, the batting order for a 12-person baseball team. How big is our total group? 12. So this is what we put in first. Does anybody in here play baseball? Does batting order matter? Like, would you ever want to be like, ooh, I definitely don't want this person to go first, or I want this person second or third in line? Would that make a difference? Yes. So because the order would make a difference, you'd want to be careful with your selection. Would that be a combination or a permutation? Permutation. If the order makes a difference to anybody, it's a permutation. How many people will eventually be placed in the batting order? All 12 people. So everybody is going to end up on that list somewhere in line. It's a fairly large number. It should be 9 digits on your screen. What's the first number you see on your screen? 4. And then 7, 9, 0, 0, 1, 6, 0, 0. There are 479 million different ways this batting order could be put together. Before we're done here today, I will show you, because you have access to permutations and combinations in Desmos to complete the homework, because I know not everybody has this kind of calculator at home. You have access to combinations and permutations in the Desmos calculator. All right, let's go look at the next one. There are 45 applicants for 3 computer programmer positions. What number should I put down first? 45. How many people are going to be selected? 3 people are going to be selected. Does the order matter? Will these people be treated differently at all? Will their responsibilities be different at all? So is it a combination or a permutation? This is our first combination. And 3 people will be chosen. This is a combination. Because everyone will have the same responsibilities once they're hired for these jobs. So out of this pool of 45 applicants, how many different ways could 3 people be selected for this job? 14,190 different ways. All right, number 4. Rob and Mary are planning their summer vacation. They would like to visit 13 different states, but they only have time to go to 9. So they're trying to decide which states to skip. What should be the first number that we put down? 13. They're choosing from 13 different states. Come on. They're going to visit how many? 9. So how many are they going to skip? 13 minus 9. They're going to skip 4 states. That's what we're trying to figure out. We're not trying to figure out which 9 states they are visiting. We're trying to figure out which states they're skipping. If they're not going to go to it, does the order that they decide that in matter? No. So I want 13 and then combination or permutation? Combination. How many from this list of 13 are they going to decide to skip? 4. How many different ways could they reach this conclusion? 715. We are halfway done with this page, guys. Has anybody been having difficulties finding the buttons on the calculator? Because I really want you to practice typing it in along with the rest of us. I want you guys to try the next one, number 5, on your own. There's a group of 45 people that are going to run a race. The top 3 runners earn gold, silver, and bronze medals respectively. And I want to know how many different ways this could possibly turn out. So write down your total first. Decide whether it's a combination or a permutation. How many people will be selected for medals? And then hit enter. enter next, and then type the second number.
Okay.
There you go. Mm-hmm. What should I write down? 45 should be my first number. P, why P?
Because they're in the same place there, so it matters.
Yeah, the order matters whether they come in first, second, or third, or at least it matters to the runner. It might not matter to us, but they're going to be treated differently on that sand. And then what do I have after this? 3. How many different ways did you guys come up with? 85,140 different ways that this race could turn out. So now I've added another question on here. Martin is one of those 45 runners. What's the probability that Martin takes the gold medal? 1 out of 45, yes. We weren't asking what the probability was that he placed somewhere in the top 3. We wanted to know what was the probability that he took first place. If he comes in first out of all 45, he's got a 1 out of 45 chance of doing that. All right. 8 girls, I'm looking down at number 6. 8 girls are competing in the IHSAA 100-meter finals. What would this look like? What's the first number I should write down? 8. Does order make a difference here?
Yes.
Yes. Now, barring any catastrophe, how many girls will cross the finish line? All 8 of them will cross the finish line. How many different ways can this happen? 40,320. I didn't mention this earlier when we saw another permutation that was just like this, where the 2 numbers were the same. When we have a permutation where order makes a difference, and all of the initial group is going to be selected, that is the same as 8 factorial. This is exactly the same as when we talked last week. If there's 8 girls running, how many people could get first place? 8 people could get first. Once the first person crosses the finish line, how many people are there still in the running for second? 7. And then 6, 5, 4, 3, 2, 1. That is only with a permutation, and it is only when we are choosing all of that group, when they are all eventually going to be somewhere in that line. All right, number 7. I've added some additional pieces of information here because there wasn't quite enough to answer the question. You just bought a safe with a digital keypad. The lock can be programmed, and the keypad has the numbers 0 through 9. So I want to know how many 4-digit passcodes are possible. Now hold on for a second. Before you grab your calculators, let's think about this. Let's start off with just how many numbers do we have to choose from? Be careful before you answer. 10. 0 counts. That's absolutely correct. 10 numbers on the keypad. Does order make a difference here?
Yes.
Yeah, if you know the 3 numbers that you need to push to open it, but you don't know the order, you're going to have to try several different things, right? So order makes a difference. When you set a code for something, are the numbers allowed to be repeated?
Yes.
Yes. Up until now, we've been looking at situations where once a choice is made, you can't choose that same thing again. It's already included in the group. So how many 4-digit passcodes are possible? So I'm thinking about how many numbers do I have to choose from for the very first digit? I have 10 numbers to choose from. Once I choose, say I choose 6 for the first digit in my passcode, can I make that the second number also if I wanted to?
Yes.
So how many numbers do I have to choose from for the second digit?
2.
I still have 10. My number of choices didn't go down. This is different than running a race. Once that first runner crosses the finish line, they can't also win second place. But when I'm thinking about making up a code for my lock or for my safe, I can choose the same thing twice. What about for the third digit?
10.
I still have 10 options. And for the fourth,
10.
I still have 10 options. So if we were going to make up a 4-digit passcode, how many different ways could we do that? How many times are we multiplying 10 by itself? 4 times. So 10 to the 4th power. $10,000. Double check on your calculator. 10,000 different passcodes. Which means just trying to guess somebody's passcode is going to take you a long time.
A 1 in 10,000 chance.
Yeah, you have a 1 in 10,000 chance of getting it right the first time.
Or you could just blowtorch the vault open.
How many non-repeating 4-digit codes are possible? Think through this with me now. If it's going to be non-repeating, how many digits do we have to choose from for the first one? 10.
Then 9, then 8, then 7.
Then 9, then 8, then 7. This is what it looks like for a permutation. So this would be out of 10 total things. And the one up above is a permutation, but I can't use the permutation button for it because we're not removing choices each time. No matter which way you type this in the calculator, you should get the same answer, whether you do 10 times 9 times 8 times 7, or whether you do 10 permutation 4. Tell me what you get when you type this into the calculator. How much?
5040. 5040.
5,048?
40.
5,040.
Yeah.
All right. So this is 5,040 different, oh, I can't spell, non-repeating codes. So what's the probability that somebody goes into a store, they buy this safe, and they make up a code that doesn't have repeating numbers? What would that probability look like?
1 over 5,040.
That would be one specific code out of all the non-repeating codes. I want to know what's the probability that somebody selects a non-repeating code out of all the possible codes. Yes.
I was going to say you should add the 2.
5,040 over 10,000. This is all the non-repeat codes. And the bottom is all possible codes.
And just to get it out of the way, why can't we reduce to 504 over 1,000?
Oh, you absolutely can. You can reduce that down. Probabilities, again, just to repeat, and I'll say this many, many, many more times, probabilities are the only time that I'm not going to insist that you reduce your fraction. Could we turn this into a percent? Okay, can you guys divide that for me on your calculators and tell me what you get? How much?
1.94.
You said 1.984? Remember, the 50/40 goes up on top, and then you divide it by the 10,000. Whoa, I heard lots of numbers all at once, one at a time. Okay, I want it as a decimal. That's okay. One more time. 0.504. So what would that be as a percent then? 50.4%. When we have it as a decimal and we want it as a percent, you would take it and times it by 100 to change it into a percent. If we were asked to give our answer back as a fraction, I would write it as like 50/40 over 10,000, or you could reduce it. I would accept that as well, although you don't have to with probabilities. If it said to enter your answer as a decimal, the 0.504. If I asked you to answer back as a percent, 50.4%. So about a 50-50 chance that somebody that buys this safe ends up choosing a code that doesn't have repeating numbers in it.
Now we got the outfit.
Let's do one more for today, and then we'll shut it down. And we'll keep practicing with these tomorrow. Thank you, ma'am. Castile and Joe are planning trips to 3 countries this year. There are 7 countries that they would like to visit. One trip will be 1 week long, another will be 2 days long, and the other will be 2 weeks long. Will these things be treated the same or different once they decide which countries they're going to visit? They're going to be treated differently because they're going to be in these countries for different lengths of time. So if they're going to be treated differently, would that make it a combination or a permutation? Permutation. So how do I write this down then? 7, because they are choosing from a total of 7 things. P, order makes a difference. They're going to be treated differently. 3. Because they're going to end up only choosing 3 countries. 210 different ways they could plan this trip. Very, very nice work today. Tomorrow we're going to keep practicing with some of the ones that are on the next page on 251, but for now I'm going to go ahead and shut it down. If you guys want to go ahead and get started on the homework, homework 2 is due on Wednesday. Other than that, that's everything I have for you today.